Yeah.
For the participants. I don't know whether you have made it live.
238 झाला है.
बस तो अभी चालू करेंगे तब तक हो जाएगा धीरे.
Repairs to buildings for more than 50 years now, and then when I did the first conservation in 95-96, I didn't know the rules and regulations of conservation, but the only golden rule I followed is use the same material that was existing for conservation. So with that rule, when I started, then I said, oh, let me go. Then I did my post-graduation in the process because I thought, let me learn the science more formally. And it's very, very interesting. You know, if you see the meaning of conserve in the dictionary, it says to protect from decay or harm. So a simple definition of conservation is to protect from decay or harm any heritage structure. So that's the job of a structural engineer, that's the job of an architect. And my today's thought processes, as I see in the field, there are very few structural engineers. If I stand corrected, I am the only structural engineer with a post graduation in conservation of heritage structures, maybe across the country. Maybe I may be wrong. Totally. My presentation is to invite more and more structural engineers into this fascinating field of conservation of heritage structure. This is my, in fact, second lecture on the same subject. First was for Institution of Engineers about 10 months back at Belapur. So let's straight away head for conservation. So what does conservation word include, or the efforts of conservation as practiced in the field include? First is repairing the structure for its present level of damage. Is that not structural engineers do for other structures which are not heritage structures? You know, we are restoring, repairing bridges, dams, we are restoring multi-storied structures. So how is conservation different from repairing? Of course, we'll come to that point also. Next is, in conservation efforts, it includes retrofitting the structure from the point of view of earthquake, cyclone, floods, etc. Natural calamities. Retrofitting is purely a job of a structural engineer. The word retrofitting means you are upgrading the strength of the structure to take care of the additional stresses or loads exerted by the natural calamities. This job of a structural engineer. Then reconstructing partially collapsed portion of a heritage structure. So when you are reconstructing, you need structural engineer also, you need architect also in the team, you need other professionals also. We'll of course see it in the later part of the presentation. Then adaptive reuse of the structure. What is adaptive reuse? You know, we are making alternate use of the structure. You must have seen one of the slides which showed that a bunker being converted into a museum. The bunker at Rajwada today is in the process of being converted into a museum. Bunker was actually a war mechanism. So it has no role in case of a wall today. And so this is being converted into a museum. And when we that is called adaptive reuse. You know, the palaces are being converted into hotels, they are being converted into museums, residential buildings are being converted into commercial structures are being converted into warehouses. So many adaptive reuses of structure are required as a part of conservation efforts. In this also, you need a structural engineer to take care of the additional load or the reduced load, change of load transfer paths, and you also need an architect to do the effective planning of the next use or the reuse of the structure. Accumulated maintenance. See, day before yesterday, there was a collapse at fort in Mumbai. You know, we all must have read about it in the newspaper. And that collapse is probably due to accumulated maintenance. These structures are 80, 100, 120 years old. And it does require maintenance on timely basis. Maintenance is a neglected subject in Indian parlance, I believe. We don't maintain our own body also. So forget about maintaining structures. One is we do not know how to maintain. We do not do adequate maintenance. So this is what I want to say when I say accumulated maintenance. Next is removing incongruent interventions. Now, what is incongruent? See, let's look at a structure which is constructed 150 years back, say. There have been many modifications, changes, additions, alterations to the structure. Some of these are congruent and some of these are incongruent. Incongruent in the sense they are totally different to the architectural style of the structure. They are add-ons, they are lean-to sheds. And when we want to remove these interventions, it is called removing incongruent interventions. See, there is a possibility that some of these interventions are even 100-year-old, and you may want to maintain them, retain them. Then you can always remodel them in the same architectural style or keep them totally different. We all have seen the addition of the glass entry and exit points outside the CSMT, that is earlier VT station. We have a basement there, then we cross the roads and come out at the VT station junction, CSMT junction, and that's where it's in glass. That's an intervention, but it's a permitted intervention. But in some cases, we want to remove the incongruent ones. We will come to those slides also. And upgrading or introducing new building services. When we are making adaptive reuse of a structure, we want to upgrade or introduce new building services. Like we want to add rainwater harvesting, or we want to add DG sets into the structure. We want to have air conditioning, central air conditioning, and so many of the building services. We want to upgrade the plumbing, which is many decades old. So all this comes in part of conservation efforts. Now let's look at how repairs and conservation compare with each other. We all, as structural engineers, I'm sure there are many architects also in this field. I've been giving lecture in architectural colleges on repairs also. So I believe repairs and conservation both need architects and structural engineers. So when we compare repairs to conservation, what is the difference between repairs and conservation? The first is, in repairs, we have unlimited freedom of material or techniques of repairs, whereas in conservation, we have very limited freedom of material and techniques of repairs. A lot of people ask me, conservation can we use polymer mortar, or can we use epoxy mortar, or can we use fiber wrap? I have used all of it. Why can't you use it? That's the reason I've used the word limited. Limited is you have to be careful about using this material while you're using conservation. You cannot be using this material at wrong locations or wrong places. How? Let's see further. In conservation, some of these old buildings are made out of stone, timber, cast iron, lime, wrought iron, and so many other building materials of which are not used nowadays in construction. So very little of this is taught in architectural or in engineering colleges now. We really do not know about lime. We really do not know about timber construction, timber joinery. We really do not know about stones. In fact, I was surprised that geology, subject purely on stones, is not even taught in architectural colleges. The architects here must raise this, because so many architects are into conservation of heritage structures and they don't know the subject of geology at all, which I believe is something needs to be changed. Next point, which always comes to cement versus lime. Lot of structural engineers ask me, conservation matlab wo sab lime mein karne ka na? I said, who said that? That's not true. But you can't be doing pointing or stone masonry with cement. You have to be judicious, you have to be careful, you have to be sensitive towards the needs of the structure when you use cement, when you use lime, or any other restoration material for that matter. Gateway of India, you saw the photograph of Gateway of India. Someone has done epoxy coating to the stone of Gateway of India. There cannot be more heinous crime than that in the subject of conservation. And I did that about 10 years back. I believe it's been taken up again for conservation. Something very interesting. Gateway of India has concrete piles. It is on piles and the piles are of concrete. I'm sure most of you did not know this. We excavated the piles to see the condition. They are in absolute strong condition after 80 years. And twice a day the rainwater, the sea water touches the piles on the side, and it's in a good condition. Concrete made 80 years back. Then in conservation, we must know the early techniques of construction. These are not taught in either architectural college or engineering colleges. These techniques are no more in use. In some cases, you will see a technique which teaches you so much about the material, timber as a material, or stone as a material, or lime as a material, but you have to learn from the structure first, think over it, come up with the solutions, and then apply. It's a very interesting field of conservation, not technically very complicated, or as complicated as it sounds. The names are very heavy. When you say incongruent intervention, you feel it's something. When I say, "Arey yaar, illegally jo add kiya, usko nikalna hai," then we really understand what it is. So, early techniques of construction is what the structural engineers must learn in the process. In the repairs, we are allowed to change the elevation or the planning without asking anyone. Whereas in conservation, the golden rule is no change in elevation or planning unless it's adaptive reuse of a structure. Again, there is grade 1, grade 2, grade 3 types of heritage structures, and heritage committee in various cities and districts have clear norms of what is permitted for grade 1 structure, grade 2 structure, and grade 3 structure. So, as a golden rule, I believe that even for a grade 3 structure, unless you're going for reconstruction of it, do not change the elevation. It's so aesthetically beautiful. Why change it? And if you were as competent, we would be making structures more beautiful than that. So why change the elevation when we are not competent to change it? Or even the internal planning, for that matter. And the last difference, I would say, between repairs and conservation is, in conservation, as far as is possible, make invisible repairs. Repairs which are not seen. Aesthetic, take the aesthetics into consideration always. It is a simple example. Then I thought that हाथ टूट गया है, and if you want to put a steel rod in between, you got a fracture, you got a steel rod in between, then do plastic surgery also. So you should not see that there is a steel rod inside. So it's as simple as that. When I say aesthetic considerations, the external facade, the face, the beauty of the structure should not be marred at all. So these are a few points of comparison between repairs vis-a-vis conservation. The professional need that is needed in conservation. It needs structural engineer. I'm putting structural engineer at the top because I'm a structural engineer. So architects, those who are present should I apologize to them. Then you need material scientist. We saw some materials, stone, timber, cast iron, rattan, lime, and so many other materials. You work with stained glass. You work with cobalt. There's so many materials which we have never heard of in the sense, never seen, never touched them also for that matter. So you do need material scientists in the team. You need architects. It's a very important role of architects that they play in conservation. The most important role is they are sensitive towards the needs of the structure. See, someone has said that structural engineering is pure science and architecture is art. I said no, it's both are complementing each other. So both are needed in any conservation project. MEP engineers, mechanical, electrical, plumbing engineers, they have a major role to play in even maintaining the structures. It's a process of training that the mechanical, electrical, and plumbing engineers must have while even maintaining the structure. Some of the slides I will show you today. I've got 4 case studies. Time is very short, so I'll be running through the case studies faster. But MEP engineers need a special training in conservation. Historians, archaeologists for archaeological structures, they play a very big role, so that you are not trying to change the history that goes with the structure, or change or harm the history that is there with the structure. and so many other professionals. You know, you need, as I said, stained glass artists. You need stained glass artists. You need people who can work on cast iron and wrought iron. You need metallurgists. You need geologists. So many other professionals are needed in a conservation team. This is a question which is asked to me so many times. Is conservation an architectural field and repairs a structural engineering field? I said, what the hell? It's nothing of that sort. There are more architects who have done post-graduations in conservation of heritage structures, and they are doing conservation. So it appears to be architectural field, but it is equally a structural engineering field. And in repairs also. Why can't architects repair the buildings? They must learn structural engineering. Like if we have to do conservation, we must learn architecture, some part of architecture, and do conservation. They must learn structural engineering and do repairs. So both are complementing each other. So I would never say that conservation is an architectural field and repairs a structural engineering field. We saw so many professions that are needed, this and that. And what kind of professionals should get into conservation of heritage structures? A lot of young boys come to me. They can we get into what kind of professionals? For conservation, only one type of professional must get into the field of conservation, and that is the passionate ones. If you are passionate about heritage structures, only then you get into this field. Lot of contractors ask me, sir, इसमें बहुत पैसा है क्या? वो पाइपर रैप करेंगे क्या इसको? अरे यार, what the hell? Don't get into the project because इसमें पैसा है. Get into the project because ऐसा project आज हम दोबारा नहीं बनाएंगे. इस टाइप की बिल्डिंग आज कोई बनाता है क्या? आज के जो पैलेसेस बनते हैं, बम्बई में भी बनते हैं, बम्बई के बाहर भी बनते हैं, पैलेशियल स्ट्रक्चर्स, but उनका आर्किटेक्चर इज सो डिफरेंट, सो दिस थिंग, इट इज रियली मतलब उस टाइप की बिल्डिंग. सी आई हैव अ फेवरेट सेंटेंस दैट पीपल यूज्ड टू create and reconstruct today. 100 years back they used to create and reconstruct today. That is the difference. Let's go to the case study. The first case study is of Wagh Mandir or Mani Mandir, Murbi in Gujarat. Those who have seen my earlier presentation, they would find this repeat. Some of the slides are repeat, but see the devastation of earthquake that is done. This is the Mandir, Wagh Mandir. It's not a Mandir actually. It's a 2 lakh square feet palace constructed by the king then, and there is a temple inside. So this is called a Wagh Mandir. Wagchi Bapu is the king who built it, and Mani Mandir, Mani is his friend in whose memory he created the palace. And this is how it was when I got it after the earthquake of 2001. But I got into the sub project only in 2010, around end of 2010, practically in 2011. So what was the structure doing for 10 years after the devastation? It was slowly crumbling and falling. See this. Even after 11 years, if you see this particular keystone, it is dangling, hanging, because the structure refuses to collapse. Structure also wants to live like us human beings. Every structure has a spirit in it, and it doesn't allow the structure to collapse so easily. Can you see this particular arch? The crown stone has collapsed till the arch is standing. It is defying structural engineering. If the crown stone falls, theoretically, as per our science, the arch must collapse, but it's standing. See a few other photographs. This is how when we got into the structure in 2010, December 2010. I think my engineer is doing the survey of the distress and damage. That's the close-up of one of the arches. There are more than 500 arches like this where the crown stone has moved from its current location. The conservation work comprised of following phases. One is propping and deconstruction at various levels, civil work like waterproofing, line, concrete grouting, structural conservation and retrofitting, and architectural conservation, stone and railway floor. The first thing we did was propping the entire structure, because as I said, it took 10 years for us to get into the structure. The history is different, but time is short. We bought 2,000 props and supplied it to the contractor, because we knew the project will take at least 3 to 4 years, and the props to be rented would have been much more costly compared to buying the props. So we bought the props on behalf of the client, 2,000 props, and propped the entire structure like this, because we didn't want further collapses or even safety of our engineers to get into for inspection and working out the quantities and costing. So this is how we propped the entire structure. Of course, those props at the end of the project were sold off to the contractor, because they were relatively new, only used for 4 years, and almost 90% of the cost was recovered. Then what we did was identified the structures which needed reconstruction. When you identify a structure for reconstruction, you don't demolish the structure, you deconstruct it. And when you deconstruct, you first do numbering in 3 dimensions, and then remove the structure stone by stone and replace the same stone at the same location when you are reconstructing it. This is how the structure was deconstructed stone by stone. Either it was removed downwards manually or mechanically. We use both the systems, because with the Hydra, the lighter stones were removed, and the heavier stones were removed with the Hydra, and the lighter stones were removed manually. Then we come to the civil work like waterproofing. The entire almost 80,000 square feet of terrace had lime concrete base on it, and the waterproofing was also lime concrete. If we removed the lime concrete entirely, if you see this photograph, the lime concrete was removed and even stacked in gunny bags throughout the terrace for reuse. The entire lime concrete was reused. Only 10 or 12% cement was added into it for early strength. We'll come to those slides later. Majority of the girders were intact, because Morbi in Gujarat is a dry weather. So the corrosion levels were low, but for 10 years, the cracks in the structure was permitting leakage into, and because of the leakage, there was corrosion and heavy corrosion of some of the members. So those members were replaced. What you can see in these photographs, those members were fully replaced. The stone slabs which were removed were replaced more or less at the same location, not that exactly at the same place, but more or less in the same region. Then mild reinforcement was tied, and the entire lime concrete was reused. The whole terrace was covered so that with tarpaulin, and very limited curing, because lime concrete is air cured predominantly, but we had also used some cement, about 10 or 15%. So that's how we cured the whole thing, and the whole slab was conserved very effectively. This is purely a civil engineering, structural engineering job, what I have shown you till then. Now let us go to structural conservation and retrofitting work. You have seen the cracking to the walls, right? How did we repair those cracking? We in some cases we even pushed the structure back, reduced the width of the cracking. All the cracks were sealed, they were grouted. Now here the question is, we did grouting with cement. We did not use lime for grouting, we did it with cement, because the surface is finished. The joints are filled up with lime, and the material which goes inside the thickness of stone masonry is we use cement as that material for grouting. So after raking the joints, we did joint filling, which is sanda barna jisko typically bolte hain, using mastic tapes, and this is how the finished masonry looks, so that there is no material which spills over the stone. Then we did 50 mm by 12 meter coring from the top of the terrace right to the plinth level. The structure was 11 meters, we went 1 meter into the plinth. So 12 meters of coring we did 50 mm. What you see here is a stone core which we removed layer by layer. You know, maybe 3 feet of stones cores we were removing. Then we put a complete 12-meter long steel rod into it, and the whole gap of 50 mm was grouted with cement and lime mixture. So this is how we created the masonry, converted the masonry from normal masonry to reinforced stone masonry. You all must have heard that there was a earthquake of 5+ magnitude in Rajkot region about a month and a half back. And the feedback that I get is there has not been any cracking to this structure because of that earthquake. I'm very happy to share that. Let me go to the previous slide once again. What you see here is a drill which is about 3 feet long, but we use up to 5 feet long horizontal drills into stone masonry, put reinforcement in it, and grouted that small hole. You know, you make a 16 diameter hole, put a 10 mm hole, 10 mm reinforcement, and grout the rest of the area with epoxy. So we are reinforcing the masonry in horizontal and vertical directions. This is how we grouted a laser look, and this is how the completed grouting. You know, it's a reinforced concrete pillar kind of. So constructed every 1.5 meters in plan all across the masonry. Now let's come to what did we do to the crown stones of about 500 arches. You know, from a small half an inch displacement to almost 8 inches of displacement. We had various cases. We literally used a truck jack. Can you see this photograph? This is a jack of a truck on which there is a simple prop. I'm going back to the previous slide. This is where we pushed, after propping it, we pushed the crown stone back and then put helifix pins across to stitch them into position. This way we could protect the crown stones, push them back into position with practically zero cost. It's just the cost of 2 labors. You know, actually the first 4 or 5 locations we had to physically stand there and show him. Then this team of 4 or 5 trained laborers were pushing the crown stones back all across. You know, 500 crown stones. You know, very limited cost. This is pure structural engineering. You got to have first the confidence that yes, this can work, and second is this idea. This is typically a helifix pin. I'm sure many of you have used it to stitch stone walls or stone masonry or the masonry stones together. This is how you put this red arrows, red dotted lines show how the pins are inserted into this thing. Let me go a bit faster than architectural conservation. In this, we reconstructed the collapsed portion or the portion which was reconstructed stone by stone, and this is how we recreated some of the portions of the structure. This is how the recreated portion looks. Very beautiful, very intricate. The entire structure was used by PWD for 40 years after the independence, and they had given coats after coats of whitewash, color wash, and even the intricately carved material was filled up with chuma. So it was looking flat and these things. So we had to manually remove it. We had to remove it with low pressure water jets, and we had to sometimes use the mist process of cleaning also. This is how we recreated the damaged portion, the cornices, the brackets, the lower portion of the column which was damaged. This had been partially replaced. The carved out idols in the temple are being recreated. The stone spiral staircases. This is cantilevering out from the this has been recreated. It is very difficult to recreate this wooden handrail. You do get karigars. A lot of people ask me, ऐसे कारीगर मिलते हैं क्या? I always say to those, बनाने वाले मिल जाते हैं, बनवाने वाले आजकल नहीं हैं. There are no Sethias who want to restore structures like this. I can very proudly announce that the royal family of Morbi, though the structure does not belong to them, it belongs to the state government of Gujarat. They entirely restored the structure through their money. Of course, I was the fortunate consultant, and it is given back to people. You know, just the lokarpan कहते हैं, they are giving it back to the people. They are planning to create a museum of local arts and crafts there. Very soon it will probably be taken. This is how it was done. This is with natural colors or vegetable colors. We created some of the painting work in the dome of the temple. We can do a bit faster before and after some of the photographs. See this photograph before and after. See the crack. The crack has gone to two floors, and this is the same portion which has been restored, and this portion has been recreated. This portion has partially collapsed. It was extremely difficult for the karigars also to do this. This is three-dimensional carving. Three-dimensional carving in stone was extremely difficult to manage. We failed 4 times, and the 5th time we could get it right. But then after that, the karigars were experts. So they reproduced the same thing at several locations. This is how it looks. Friends, one thing I can say that this structure could not have been restored without a structural engineer, a hardcore structural engineer in the project. This was purely 90% of the project was structural engineering and only 10% was architectural aspects. If we wanted to reconstruct this structure, the cost, very jada estimate, mota estimate could be more than 500 crores. But we could restore it in less than 20 crores. So that's the kind of effects we can achieve if we use the right techniques, make new techniques of restoration and conservation and apply them. This is how the structure looks. Very beautiful. If you go to Rajkot, it's just 65 kilometers. I would request you to go and visit the structure. Next is Taj after the 26/11 terrorist attack. Who doesn't know Taj? We all know what the structure went through on that fateful day. For about 60 hours, those people were there. 5th and 6th floor is where they were confined to, and then they did a lot of burning and hand grenade blasts, bullet blasts. Can you see an arrow here? Beltar suite. This dome here is a presidential suite. This is the north side of the structure, and on the south side we had a similar dome called Beltar suite. This dome was entirely burnt by the terrorists during the 60 hours of carnage. This is how the Beltar suite looked before the terrorist attack, and this is how it looked. If you see this pilaster of the handrail, I'll go back to the previous slide. This is the same pilaster. The angle is different. Here it is from the ground level, means the 5th level you are showing the photograph, and in this case it's from the 6th level you are showing the thing. But this is the dome which has fully collapsed, which was burnt down, and it has fully collapsed. There were no drawings available of the Beltar suite dome, but luckily for us, the drawings of residential suite were available, and we could use them. We took physical dimensions of residential suite and reproduced that in Beltar suite. This is how we first made the architectural drawings. Then this is how it was created, or rather recreated on the site. I can tell one episode which I tell in every lecture of mine on Taj. This must be a 10th or 12th lecture on Taj. What you see, every wooden member here is Burma teak, and this particular member is 1 foot by 2 feet size Burma teak. People talk of inch and 1 inch by 2 inches of Burma teak. Patti is what we call it, Burma teak patti. This is Burma teak members, massive members. The cost of Burma teak in one Beltar suite is about 42 crores, 1.75 crores, and majority of it is going above the false ceiling, almost 60-70% of it. So when I went and asked the project director, I said, boss, majority of it is going above the false ceiling. So why are we using Burmatic? Why can't we use Ghanatic? We can reduce the cost to less than half and straight away 1 crore rupees bach jayega. We said, what was the earlier board? I said Burmatic. He said, just go ahead and use Burmatic, because our chairman then, Sir Ratan Tata, would be announcing in the media and people at large that we have restored it to its lost glory. So if it was Burmatic, use Burmatic. See, that's the integrity of Tata Group. It's amazing. I feel so happy that this project came my way and I could finish it properly. The next is Taj Club dining area. This also was fully burned down. This also had to be recreated. You can see the openings in which structural steel and wooden members. You must be wondering what is structural steel doing. You can see the structural steel number here. I will tell you when it comes to that. Let's look at the wooden handrails. That this is how it looks today, and this is how it looked even prior to the terrorist attack. On every floor, if you see this design, and this design is different on every floor. You can see it. So it's not that they are the same. So conservation means you have to identify which design existed on that particular floor and use the same design and copy it. You can't blindly give instructions to contractors. You've got to be sensitive about the needs of the structure. This is how the skylight after the attack, the railing is fully burnt down because it was wooden. The columns are burnt down. Now I will come to the point which I mentioned. This is fifth floor, and this is fifth floor, and this is sixth floor. The structure was constructed somewhere in 1903. It was only 5 floors. Somewhere in early 60s, they thought that you can make use of the double height that was there on the fifth floor and introduce a slab in between. That is why this slab is in structural steel and concrete. You can see some photographs. You can see this is how the sixth floor was developed in structural steel and brickwork. And in this 6-inch size brickwork, you have structural steel columns. What you see here is a structural steel column embedded in 6-inch size brickwork. It's a very fabulous construction, but it was a nightmare for me because unfortunately no drawings were available. And when we exposed it, now we had to retrofit it for the earthquake resistance. So retrofitting the structure which was built in say early 60s for earthquake resistant codal provisions of 2008 was a very interesting challenge. The photographs what you see here are the hand grenade blast attacks on the floor. This portion is burnt down. What you see, this is a project where I had an opportunity to work on 4 building materials: stone, bricks, steel, and concrete. The same. You don't get to work on these many materials in one structure. This is how it was. There is corrosion also. You can see in 50 years, some of the ISSE slabs have corroded also. So we had an opportunity to restore the corroded portion. Fire damage. This is how the glass roof was burned down. You can see aluminum sections of this is burned down. This is another photo of the bell tower suit, and this is again Taj Club. This is what is quenching. You know, when you heat the stone, and when as a firefighting effort, water is put on the same material, it quenches. And it sometimes leaves layer by layer. So this damage, what you see, is by the process of quenching. Bitumen coating on the roof was totally. We took that opportunity of restoring bitumen coating. You can see the water stagnation. The entire waterproofing was redone. The complete MEP utilities were because it was historic growth that structure had undergone. We took the opportunity of realigning the complete MEP of the structure. This is how it was backing, and this is how the structure stands proudly today. Again, in this project also, what I can impress upon is this also is predominantly a structural engineering dominated conservation project. Let's go to the third slide, which is again a structural engineering dominated Rajwada at Indore. Indore was a 300-year back small village, which was a military padao for the workers. It derived its name from Indreshwar temple, and the Rajwada which we see is more than 250-year-old structure constructed by Devi Ahilyabai Holkar. This is how the completed Darbar Hall of Rajwada looks, but this is how when I entered the structure it was. Devastated by the fire of 1984. In 1984, after the assassination of Madam Indira Gandhi, there were riots against the Sikh community, and there was a shop of a Sardar just abutting Rajwada. And after this, the the shop was set on fire. It engulfed Rajwada also, which was constructed in wood and stone. And this is how the Darbar Hall looked. The project was divided into phase 1, in which we do Ganesh Hall and Darbar Hall, and phase 2 is a 7-story entrance facade structure. 7-story, yes. 7 manzilana building, 250 saal pehle. The lower 3 floors are in wood and in stone, and the top 4 floors are in wood. It's beautiful, but I'm due to paucity of time, I'm only covering the phase 1. It has just 3 different styles of architecture: French style, Hindu style, and Islamic style of architecture. Luckily for us, these are more than 100-year-old photographs of Darbar Hall. You saw the photograph. I'll show you the slide again. We saw this photograph. The same photograph you can see 100 years old. This is how it looked. So from this photograph, and in fact, we enlarged this photograph manifold, and from this we tried to find the kind of carvings, the kind of columns, and the kind of chandeliers and things like that. The false ceiling that is there, the design in false ceiling, the design of the cornices, and tried to reproduce to the nearest. I won't say we have 100% reproduced. It's not possible because a photograph clearer than this was not available. So we tried to reproduce the structure as closest to the original as was possible in those days. The entire stone came from quarries near Udaipur. Where originally the stone used was from the same location? No, originally the stone came from Madhya Pradesh only, but those quarries where the yield was over, so we had to use the stone of same geological classification. This was an archaeological site, so we had to use stone of same geological classification, and we searched for it in several quarries, and finally we found it somewhere near Udaipur. So that is where we procured the stone. Carving was done partially at the workshop itself and then brought to site. This is how the semi-dressed stone came to. This took us about 6 months in the process. What we had done was we had started erecting the concrete columns. Now you would say, did you hear concrete? You would say, Chetan, did you say concrete? Yes, I said concrete in an archaeological structure. Why? Let us see. Because these columns, were they originally 250 years back in concrete? No, not at all. They were in stone. But these columns, I can show you a photograph. In fact, let us go to the earlier photograph. In this photograph, you can see that they have lime concrete plastering, lime plastering on the columns. So it didn't really matter whether there was stone inside or there was concrete. We could have still used stones, but the stones of this length, the delivery period of 11 months, and project couldn't wait that longer. So we took a decision of going for concrete. So one of the intricate solutions was structurally connecting these columns with the lower floor, with the Ganesh Hall, which had load-bearing walls. So first challenge was to connect these walls, RCC columns with the walls below. Next challenge was one column is made up of three different materials. One is in partially concrete, then stone, and then steel. There are stone beams, but stone beams could not give us the requisite earthquake resistance. So we had steel beams in between welded earthquake resistant connections, and then had cladding with stone beam. Of course, the cladding was also 8-inch thick. This annular space was filled up with lime concrete entirely. This is how we had earthquake resistant pins welded, to which the new steel member was welded. This is how you can see a column. If you see the column here, this is RCC column on which you have a steel column and a stone capital was woven into the steel column. Some portion of it comes out. Again, the next steel column is welded to this, and we take it out. Because otherwise, how would you bring the stone columns in between? This is how it looks: concrete, stone, and steel again. And these are the steel beams which are at the roof level. This is how the final carving being done to the cornices, to the column capitals. And this is how the final system it looks: concrete columns, stone capitals, steel columns above, steel members, and RCC slab. Again, you would say, Chetan, are you out of your mind? Did you say RCC slab? Yes, we did RCC slab because there was to be a false ceiling. In fact, I did a presentation on this a few years back in Bhopal, and there is a NGO where there are a lot of people, the architectural teams of that NGO were present, and they thought, oh, you have done such a major crime. So one young architect stood up and said, how could you use concrete in the archaeological structure and blah, 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 blah. And so luckily for me, there was an expert of English heritage from London who was attending that lecture. And he stood up and said, can I interfere? And he said, what this gentleman has done is really right, because something which is not seen about going above the false ceiling can really be in a different material. So try and understand, friends, material, like to like material, yes, it's a must, but if it is going beyond a false ceiling or beyond the visible this thing, you can always use different material, modern material smartly. Let's go a little faster. This is how the stone carving was done. These are all structural cum architectural elements. Stone beams. You can see the size of the stone beams. Up to 16 feet spanning stone beams were used. This is how where the cornices were broken because of fire. This is how stone cornices were created and fitted into this. This is how it looks completed. Partially damaged stone was repaired using plastic mortar. Plastic mortar is lime, little part of cement, stone powder of the same stone, non-shrink additives, water, and little surki. If you don't mind the reddish color of surki that it gives. This is how by medium pressure or high pressure the stone was cleaned, and this is how the clean stone looks. This is fully blackened marble, but it shines so beautifully. Where is it from? This is how it looks. Then we used lime in rendering of the internal columns. I showed you these are concrete columns where the rendering is being done. Lime mortar is being used to develop the architraves also entirely internally. What you see here is developed in lime mortar, and this is under creation. We had master craftsmen, carpenters. We used to call him Chacha, and the project was there for 3 years, and all the 3 years he kept on saying, "I'm 80 saal ka hu." So he didn't age actually, and in fact after the project also he worked on few of my projects. Master craftsman. You can see 4 generations from 80 years to 80 years worked on the project. So it was a beautiful memory of recreating Rajwada. We got a few international awards for this project, but the best compliment that I got was, while I was, this is how the structure I got, this is how I completed it, and I was standing here somewhere. Here, if I can show, I was standing here somewhere and trying to find out what finally needs to be done in the spacing, and then suddenly a very old guy came and stood next to me because it was a public place, so people used to come in and out, and he was looking at the structure. So I thought there was something different about that guy. I asked him, "Chacha, kya dekh rahe?" तो he says, बेटा मैं मेरे पिताजी के साथ एकदम छोटा था तब ये यहाँ पे आया था, लगभग वैसा ही दिखता है जैसा मेरे को याद है. So that's a big compliment, if you are able to see, this is an opportunity to recreate, and I believe that this is predominantly a structural engineering job that I did, of course with a lot of architectural inputs, but predominantly a structural engineering job. Let's go to the fourth and last case study. How much time do I have? Yeah, I still have 10 minutes. I can time. Conservation of Chhatrapati Shivaji Maharaj Terminus. This structure also loves me. I always say the structures choose me for conservation. As I said, every structure has an Atma in it, and the Atma chooses who would be the conservation professional who will be conserving. So VT station, जो पहले हम उसको कहते थे, now it's called Chhatrapati Shivaji Maharaj Terminus, has some dil ka rishta with me, and it chooses me. In 2001 to 2007 or 8, I was involved in doing the first level of engineering conservation of the structure. Now again, from 2019, we have been involved in doing the engineering conservation. I'll be showing you both what we are doing currently. Of course, for the last 3 to 4 months, because of this pandemic, the work is closed, but I'll show you what we are doing currently and what we have done in 2001. This is how the structure looks. Magnificent. Every nook and corner of the structure is decorated, intricately carved, just beautiful. This is how the Statue of Progress looks. People, what we see in this photograph is a small Statue of Progress, but it's a 22 feet tall statue and weighing about 5 tons. I really do not know how they must have taken it to that height, about 143, 44 years back, to that height, 5 tons without cranes or anything. I still have, whether it was a chain pulley block of that capacity they had with the tow, or manually it was taken up by some technique, I really do not know. But it's there at the top, and I have been fortunate earlier to be able to go and touch this beautiful lady. And now also I would have an opportunity when we take up conservation of the dome to again go and touch. This time I'll sure take a photograph of mine with this lady. In 2002, 2003, a selfie wala style tha nahi, so I don't have a photograph of mine standing there. So this is how the structure looks. Very beautifully carved. These are gargoyles. Gargoyles is where you allow the rainwater to come out of the structure. How beautifully these gargoyles are carved. And you know what? The span of these gargoyles, cantilever span, is 6 feet, 1.8 meters. So it's a 1.8 meter cantilever at a height of about 160 feet. It's beautiful, and it's single stone. That much of anchoring back, it has not moved even 1 mm in this 140-45 years life of the structure. You can see this is a single stone peacock. See, what I see in this structure is all this cobra, this owl, pigeon, these are all Indian birds, Indian flora and fauna. So I'm sure Frederick Stevens would have given freedom to the carvers to say, he must have just given them space कि यहाँ पे आप फूल पत्ती का डिजाइन बनाओ. They must have shown him a sample. Sir, ऐसा डिजाइन बनाए, and he would have said yes. That's what I feel. And for the knowledge, Frederick Stevens was architectural engineer. If you go to the net and see who he was architectural engineer. Even today, in UK there is a 5-year course which says where you get a degree of architectural engineer. So he was an engineer in the PWD then. So let's not feel shy of saying that I am an engineer and I am into the profession of conservation. I would in fact invite more and more structural engineers to get into the field of conservation. This is, see, but we must have sensitivity towards the requirements or the needs of the structure. Can you see this? This is a emblem of GIPR, Great Indian Peninsula Railway, and typically in those days they used to do it in different materials. So you see it in cast iron, you see it in stained glass, you see it in wood, you see it in stone. The same emblem they would see in different materials. You know? This is the main grand staircase, which is 9 feet of cantilever here and 13 feet of cantilever here. Not even quarter of an movement, despite these 5 or 6 major earthquakes around Mumbai. But Mumbai has seen so many earthquakes, you know, from 300 kilometers to 700, 800 kilometers, but it has shaken Mumbai. Not even quarter of an movement in this cantilever. So I really want to study someday the anchorage that they must have done to these 13 feet cantilevers. You know, beautiful. This is the octagonal dome, which is leaking today. Beautiful dome. See, this is what the British did. Beautiful structure, and this is what we did to the structure. You know, you can see the pipeline. You know, very insensitive way of putting the pipeline into the structure. Could it have been from inside? Probably yes. You know, we could have done it from inside, but very insensitive way of doing. And that's where I said the MEP engineers must have training of conservation if they have to be deployed on maintenance of heritage structures. This is again another mistake of maintenance engineers. Too many tanks. When I took the job, there were 22 tanks of different sizes, different materials, all across the flat terraces throughout the structure. We reduced them to 5 tanks, and out of those 5, 3 tanks are the original tanks, including the original firefighting tank, which was recommissioned. We reduced it to 5 tanks, and they still survive with 5 tanks, as I understand, even after what 19-20 years. This is how the jaw of the lion on the gate pillar was replaced. Same geological classification, same design, and when I replaced it, you know, somebody took a photograph and put it in the some professional who was not happy, probably wanted to do the job himself. You know, professional innovative to chalti rehti hai. It got printed in the newspaper that, oh, see, they have used a different stone. Today, friends, if you go and see, after today is for last about 10 years now, if you go and see, you can't make out which stone is new and which is old. You have to give time for the stone to weather out. Because the lion was 120 years old, 140 years old, and the jaw was new. So it took 5 to 6 years for the jaw to weather out, and it looks exactly the same today. You can't make out which of the jaw of the 2 lions was broken. This is how it was. I'm sure you have seen this photograph used to come in newspaper every year before the monsoon. They used to put raincoat to the entire structure. When I took the structure, we removed the mangrove tiles, removed the battens entirely, replaced the eroded wood completely. The wood which was good was not replaced. This is typically what is conservation. You should never overdo in conservation. जो खराब है उसे छोड़ना नहीं और जो अच्छा है उसे तोड़ना नहीं. This is the principle of conservation. In fact, this is the principle we follow in repairs also. This is how we put first the vertical battens and then the horizontal battens. We put polymerized bitumen membrane on the entire roof. This is how it goes. What you see here is a lead flashing connection of the sloping roof with the wall. This is typically how the connection was done, by making a groove. What you see, a groove in the wall, and the lead flashing goes into the groove. I can proudly say, friends, even after 19 years today, there is not even a drop of leakage in the entire structure. This lead was stolen in some cases. You know, लोग वहाँ पे चढ़ जाते हैं रात को और काट के lead लेके जाते हैं as a theft. So that had to be replaced, and some tiles were broken. Otherwise, this roof has been doing very, very well. I had given them a verbal commitment of 25 years, and 19 years have already passed. Not drop of leakage still. This is how it was done, and this is how when it was completed. More than 75% of the old tiles are reused. And broken clay tiles of the same design were brought in. Now, today, what I'm facing is different type of a challenge. These columns are cracked. This column has a mild steel pin inside. This is a stone column, which is connecting this stone to this stone. And the mild steel pin that is inside is corroded. It is swelling, and because of which it is pushing the column outwards. So it's a great material and structural engineering challenge. See, this is how the column is, which is supporting the arch above, and this is the adjoining column. So this is good column. This is column that is a crack. So many columns have cracked like this. This is a great engineering challenge. Second engineering challenge is the pediment. You must have seen Central Railway got a lot of bad publicity, courtesy some NGO, So they got it printed in the newspaper that they have done a wrong job, bad job, this and that. What you see here is the original drawing of this pediment as created by F.W. Stevens, Frederick Stevens. There is a lot of difference between what he has drawn or envisaged and what was there on the site. So already there is a difference, so no one knows what is original. So this is a challenge that we have today in redesigning. So through this platform, I would like to request people, if anyone has any slide, any photograph of the earlier this structure before damage, please pass it on to me. I would definitely give a credit to that person in all the literatures that I will, publicity materials that I will be using, or even Central Railway can give that credit to the person. And the third challenge that we have is leakage to this dome. The central dome is leaking profusely. So what you see is a drone survey. We did, what you see here is a drone, and this is a photograph from a drone. So because to climb the roof from inside, this is a drone, this is the drone taking off. Internal leakage, can you see the leakage here, here, here? This dome is of comprised of two different stones in a cross section, and four different levels of stones in across the vertical cross section. 1, 2, 3, and 4. So it's a very intricate, and no drawings available. The original drawings that are available do not show the structural connection. What the technique that I must use to stop the leakage cannot be seen from anywhere, either inside or outside. So it's a very interesting challenge. What I'm going to do it, I will do it, I'll say, when I complete it. So this is how these are engineering challenges. And something I would like to mention. Very sadly, these three engineering challenges which we are struggling today with have not been mentioned in the exhaustive report that was prepared by some professional NGO just prior to my taking over the project again in 2019. These things have not even been identified. Probably they did not have a structural engineer on board who would have identified these problems and probably given the solutions also, which is very unfortunate. So I would request the architects who are present to have structural engineer on board in every conservation project right from day one. So friends, thank you very much from passionate professional for listening to me patiently. Of course, you did not have a choice to talk to me in between. So this is where I thank ISSE and Ultratech for giving me this opportunity to share my thoughts with you, and hope I am on time. Thank you very much. Over to you.
Yeah, thank you, sir. Thank you for the enlightening lecture. You have connected ancient era with the today's material with the today. So thank you very much. There are a lot of questions which are pouring in. One question in my mind which is there is, I will like to ask you, is what is the care you have taken to create or develop a bond between the old material and the latest material which is used? How the chemistry has been matched?
Very interesting question. If we are bonding stone to stone in a stone masonry, lime is good enough to bond. We need not use any strong chemicals that are available currently. We need not use any latex. We need not use any other bonding material like epoxies or any other matters. If you are using wood to wood connection, then of course there are nailless joints also available. You can design torsion using these nailless joints and design the joints for torsion. And if it is concrete to concrete, old concrete to old new concrete, then you can of course use epoxies or any other bonding material. But if it is stone to stone, lime is good enough. And if you want to structurally connect them for earthquake, it is good to use brass or copper pins also, or even stainless steel pins. You showed in my introduction Hajeli Dargah. Hajeli Dargah is being recreated entirely in marble, only in marble, no other building material, no stone, no bricks, no concrete, or no steel. We are using only stainless steel and not stainless steel, sorry, we are using only copper pins and brass pins for structural connection. We are even doing dovetailing of stone to stone in marble for earthquake resistance. So you can develop the bond using either structural connections or simple lime also.
So one more question. In that Rajwada Palace of Indore, which you have restored, and you had columns at the upper level, which has where the load transfer was on the load bearing walls below. So how that calculations were done, because there were no drawings present with you for the load structure. So how it was done?
It's very simple. If you go for fundamental calculations, today the generation tries, they only know STAG. Many new young structural engineers, they take our interview when they come for interview. Sir, which softwares do you use? I said, of course, I stopped taking interviews long time back, but we tell them we don't use softwares. We do it by hand. Then they are puzzled. Can there be somebody who is doing it by hand? So I personally believe that you need to do two-dimensional analysis, because three-dimensional analysis is very tough to do manually, but do two-dimensional analysis manually. And even check it in STAD. STAD gives you the option of designing connections. You need to identify, and it requires a little bit of judgment to know what is the fixity that you can. Today I have a challenge of conserving cast iron building, the Esplanade Mansion building. We have been appointed by the court for that project. And it's a challenge because it's a cast iron to cast iron connection. So what kind of a fixity that can assign? Wrought iron beams to cast iron columns. What kind of a fixity? So you have to do a lot of reiteration to get to the structural connections. But joining a load-bearing stone masonry wall with a concrete column, you need to have a padding member beneath, and that padding member has to be connected to the stone masonry wall with gravity. The horizontal forces, for taking care of the horizontal forces, you can use steel pins, but otherwise it has to be predominantly by gravity. This is what I can say.
Thank you, sir. Thank you very much. A lot of questions are pouring in. Which type of waterproofing process is considered for this type of works? I mean, is there any specific process for heritage structure, or it will be done as usual waterproofing?
We can use lime cement waterproofing also if there are flat terraces. We saw CSMT, that is VT station. We saw actually what we did. It's very effective, and we have been doing that on other heritage structure sloping roofs particularly. And we need not see, even in repairs, we are traditional kind of consultants. We still try and use cement because I believe cement is one of the wonder chemicals which is a good waterproofing material also. So even in repairs we use majority portions, we try and use cement and try to do waterproofing using cement alone with non-shrink additives of course. But people can really use, suppose on a flat terrace you want to have bitumistic shade, If the terrace is not going to be used, it can be really used. As I said, the modern materials are not a no-no, but VT station roof cannot be restored. If you have a China mosaic roof, you cannot use a bitumistic asphalt on the top. So you have to go for lime concrete, brickbat cover, lime concrete. Brickbat is purely used for achieving the slope. Lime concrete and do China chips on the top. So any technique is good, provided it is not seen in aesthetics. If the terrace is a usable terrace, then you have to take care of it. But otherwise, lime cement combination is very, very useful according to me.
Okay. What are the major challenges for repairing the structure in today's scenario? Because these structures are constructed in olden days, and the designs and construction is where the design and construction is entirely different. So, which challenges you feel are the greater challenges in today's scenario for restoration?
Boss, I would say the one and only challenge is come out of this mental block that these are different types of construction. Nothing is different, boss. Nothing is different. Once you try to learn, see, we get along so well with our grandfather. And if you are fortunate and if a great grandfather is alive, we get well, get with him or her, grandmother, grandfather, get well with them so well. Why? Because we love them. We try to understand them. They love us. They try to understand. So if we love the structure, all these techniques are based on pure sciences of nature. Most of the construction is gravity-based construction. They don't have unnecessary cantilevers. Of course, forget about VT station and other structures. They don't have unnecessary cantilevers. They are gravity structures. So do not try to import something unnatural into the structure. First, the major challenge coming to the point is do not get into the thought process that, oh, this is very difficult. It's not difficult, friends. It's the structures are more than eager to tell you. Just learn the language by starting the interaction with the structure.
Okay, there are two questions which are related to Chhatrapati Shivaji Maharaj Terminal Station repair. One is how were the cracked column repaired in that station, and the other question is if vertical drilling is done in the stone or brick wall, will it damage the existing structure?
How is the solution being worked out? As I said, once I finish the job, I would give a separate presentation through Ultratech and ISSE on Chhatrapati Shivaji Maharaj Terminus, because we are in the process of developing, and we have submitted our proposal to Central Railway, and Central Railway is getting it vetted from a very prestigious structural organization called CBRI in Roorkee. So it would not be right on my part to say what we have given now, because it is not yet an accepted system. But I feel very confident what we are doing is acceptable, and I can tell you that nothing will be visible after the restoration of these columns is done. And the second question was whether we would be doing through drilling. No, we are not doing through drilling through these columns or anything. So there is no question. See, Central Railway CSMT building, Chhatrapati Shivaji Maharaj Terminus, is grade 1 and a World Heritage Site. So the challenges are really very intricate. Nothing should be visible. What we repair should not be visible. Externally, it should look as if nothing has been done. When somebody comes to your project which you are finished and says, "Arey, isme to kuch dikhta hi nahi, aapne kya kiya kya?" That's the success story. So we would be using a technique for the domes also. We are, in fact, we would have used this technique before this monsoon, but because of the pandemic, we could not use it. But I hope and I feel confident that before the monsoon of 2021, this dome will be leakage free. There are a lot of turrets, the sloping roofs, other stone sloping roofs also are leaking, so they also would be taken up. So,
Yeah, one more question to the same structure. Like, how do you repair the corroded MS pins inside scrolling column for this building?
I will, okay, I'll give you answer in brief. We do have sacrificial anode techniques. So we would be inserting sacrificial anodes, connecting them structurally to the pins, and it's like a microsurgery that we would be doing through a small hole that we will be drilling to the stone, and that stone will be patch repaired, and then the cracked portion will be grouted and externally sealed with lime concrete of the lime plaster of the lime mortar of the same material, same stone powder and things like that. So this is the technique. Since there were two questions, I tried to. It is sacrificial anode technique that we are trying to use in this case, so that we will not be able to remove the corrosion, but we will be able to arrest it at this level.
Okay. The other question is how to strengthen the old column for seismic resistance.
It's very simple. See, you can go for structural state. See, what is seismic resistance is you need to check the column in between, and you need to check the column at the two ends, the connections. So if the column is unsafe in between, you will have to increase the size or whatever. If it is a stone column, how do you increase the size? So it is not possible. If the column is safe in between, and you need to then only check the connections at two ends, you can use metallic pins either externally connected to the roof above or roof below, or use pins inside the stone column. If it is a wooden column, you can really go for patching up of additional wood. Patching up of additional stones is not possible, and in stone masonry you can't do fiber wrapping also. If it is a concrete, see, we have done fiber wrapping to 200-year-old structure. It was a masonry which is 200 years old, and it was a mud masonry structure. So we have done stone fiber wrapping to that kind of a structure also. But if the fiber wrapping is seen, then the whole purpose is lost. So if it is a stone column which needs strengthening for the mid height, then it's a challenge. You can't do much about it because of slenderness or whatever. Reduce the load and try and do the analysis again. That could be one of the thought processes.
Okay, there are a lot of questions which are again coming in, but then now due to paucity of time, we'll take last two questions. The first question is, how do you see the applicability of retrofitting structures using FRP in India?
Why not? Definitely, we can, as I said, we can really use any modern material. I go to the extent of saying that if fiber wrap and cement and epoxies and everything was available as a material of construction to these people who created these structures 200, 300 years back, they would have surely used them. We can use them, but see, it is like these structures, majority of them are gravity-based structure based on the natural sciences. So when you use a very strong material in some portion of the structure, you are creating structural imbalance. You are creating stress concentration zones in some portions, which should be avoided. If you are able to give uniform stress, see what, like a human being, if he gets stressed, he dies early. Structure also, if it gets stressed, it dies early. So we need to give uniform stress throughout the member, then the structure or the member will last longer. If we go for stress concentration zones, then there is a possibility of that area getting fatigued earlier, separating it from the rest of the areas and things like that. So FRP, definitely, why not? Any other kind of fiber wraps that could come up. See, today we are talking of fiber wraps. There could be newer techniques with the 3D printing plotters and this and that. So many new developments will come. They would be, all of them we will be using in the restoration techniques. But you have to be sensitive towards need. Do not use a material that is excessively stronger compared to the parent material structurally. And do not use a material which looks like a dhabba, it's a black patch in the Gateway of India, restore करने में अपने स्टील का पिन लगा दिया. So somebody Tomorrow, if I have to restore my cheek and there is a scar on my cheek, I would not like. I would go for plastic surgery. So go for plastic surgery in that cases.
Okay. And the last question which I will be asking to you is, how you have handled the situation where the material, peculiar material required is not available or it is too costly to afford?
See, costly is the challenge of the client. No, it's not my challenge. So I have not bothered about it. But there is no material which is not available. In one of my sites, I had to use cobalt. But the cobalt I could import from a European country. It was available. It was not available in India, but we could import it from a European country. I'll tell you another example. Pune University case, it's a grade 1 building. The handles were made of porcelain with a mark of the crown of Queen Victoria on it. So we had to develop a few about 125 new handles, and one sample was available. So somebody said, "Oh, sir, these handles are from Belgium." You know, one of my architects from my office. So we promptly wrote to 2-3 companies in Belgium. They gave a quote of some 16,500 rupees per handle, plus taxes, plus import duty, blah 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 blah. It went on to few thousands. I said, what the hell, यार हम लोग मंगलयान भेजने वाले लोग हैं, चांद पे पहुंच गए हम लोग. We are having 2,000 kilometer range missiles. Why can't we have porcelain knobs? We literally sent an engineer to Muradabad in UP, and from a small foundry, we could make those for 125 or 135 rupees per sample with the embossing and marking and everything. So everything is available. You need to scout around, and we brought the cost down substantially, and we did a perfect original conservation job. So this is how it is. I don't believe that any material is not available. It is available. कारीगर नहीं मिलते, मिलते हैं. You got to search for them. You got to pay them their dues. And then, as I said, the price is the challenge of the client. And sometimes client really does not have the budget, really does not have the money. So that is where you don't try to put the wrong material. You leave it at that and say that, sir, itna mein chhod raha hu. We will do it later when you will have some funds for doing this. It is better not to do a job of conservation than doing a wrong conservation. Structural conservation must be done, and you can really bring the cost down substantially in doing structural conservation. Architectural conservation is expensive, but it's not a necessity for the structure to live. Somebody can do it 5 years down the line when the client has money. This would be my answer to the question.
So thank you, Chetanji, for answering those queries. Now there are a lot of questions, but then we will be sending those responses through the email to the respective persons. So now we are at the end of the program. I will call Mr. Hemant Vadalkar to give the concluding remark and vote of thanks.
Yeah, good evening,
Hemant.
everyone. Yeah, it is extremely important session, an extraordinary session by Mr. Chetan Raikar. So on the behalf of ISSE, I must compliment Chetan for enlightening all civil engineers on the conservation aspect. He talked about different type of projects, starting with the Wagh Mandir, very challenging project, then Taj Hotel restoration, Indore Palace, and our beloved CST terminal. Both are the projects having their own problems, but how to tackle the problems and find the solutions, that I think Chetan has explained very nicely. Very important point he has emphasized, and I think all the structural engineers must understand that structural engineers play very, very important role on this type of conservation of heritage structure as well. So of course, architectural inputs are definitely required, and there has to be proper blending of structural engineering as well as architectural features. So I think that point is very important point Chetan has emphasized. And second important point to take away is basically what you have to have is minimum intervention in the original structure. I think that is a very, very important and very, very intricate point. We must maintain the structure as it is with a very minimum intervention. Whatever repairs you do, whatever strengthening you do, that should be hidden behind the structure. I think that is a very valid point he has told all the engineers, because otherwise, I think many people, we have seen the stone facade being painted from the external face. That is very bad. Or they rake out the joints and do the pointing, which is seen from the surface, which is very bad, which is not to be done. Third important point, I think what he has mentioned is you have to have the compatible material. Definitely, when you do the restoration work, you cannot blindly use the available latest polymer mortars, which are of very high strength. So we have to use the material which is really compatible with the original structure. I think that is also very, very interesting point, very important point. So that's why he's insisting to use the lime mortars wherever required, of course. So I think these are the some important key points one has to keep in mind in the repairs and the conservation of all the heritage structures. And I request Chetan all the time that you write the articles for our journal so that we'll try to publish something in a form of some booklet or articles, which will be helpful to all our fellow engineers, definitely. Because Chetan is inviting all other civil engineers and structural engineers to come into this field. So I think, Chetan, you are creating competition for yourself by inviting all the other engineers. But definitely, that is the need of the hour. Definitely, we should do that. And then there is sensitivity, I think, very, very important key aspect. So we have to be sensitive towards the structure. We should not damage the structure in doing any kind of conservation or strengthening. So I think these are the very, very important points highlighted by Chetan. And we expect more presentation from Chetan in future from ISSE. So on behalf of Indian Society of Structural Engineers, I thank Mr. Chetan Raikar for this excellent lecture on the conservation and heritage structure. How do you do that? I thank the entire Ultratech team, including YTVV Prasad sir, Mr. Arvind Mahajan, Ashish Sontakke, for providing this platform for conducting our session and webinar. I also thank the entire ISSE team, Mr. Shantilal Jain, Paresh Unarkar, Ranganath Satam, Mansi Nandgavkar, Madhav Chikodi, Mayur and Raunak for supporting this platform. And I, of course, thank all the audience, the civil engineers, then the architect friends who are attending this webinar in the large numbers. So thank you very much once again for joining our program. And those who are not members of ISSE, I appeal again, please become our members, strengthen our organization, strengthen our hands. And this is a platform we are creating for knowledge sharing. So we are inviting all the experts like Chetan and other experts to share their knowledge and experience for the fraternity and betterment of civil engineering in future. So thank you very much. And we'll just log off from this. Thank you all again.
Thank you, Chetanji. Thank you.
Thank you very much, everybody.
Thank you, Chetanji.
Thank you, sir. Thank you very much.
Yes, thank you.
Thank you all the team members.
Thank you, sir. Thank you.
Yes.
I'm logging off. Thank you.
Thank you, sir.
Yeah, thank you. Thank you all.